So going on ahead, I hope you're able to hear me better now without any audio issues and able to see the screen clearly as well. Perfect. Now that there are no issues, no more issues, let us go back and continue ahead from where we left off. So the basic point that we are going through in this session is continuation of inheritance in C++, and then we'll move on to Java. So within inheritance in C++, we know that there are four different types of inheritance. Remember, there are three types of inheritance based on the access specifier you use. There are four types of inheritance based on the kinds of inheritance you perform. So we have single inheritance, which, as we know from earlier, you have one base class and one derived class. The derived class is inheriting base class. Now, take one more example. Let's say you have a base class called operations. Now, operations as in it could be having something like a square function, cube function, and so on. All these sort of functions. Now, you have two other classes called, let's say, circle and rectangle. Or instead of rectangle, I'll just use square. Now, if I'm using area function in circle class, that area function is gonna, as we know, is pi r square. We are doing square function here, so I can inherit the square function. Similarly, in square function, when I calculate area, basically what we are doing is calculating side into side. Again, side square basically. So even here, I can call this square function as well. So both these classes can utilize one function of operations in them so that they don't have to rewrite the code. Rewriting of the code is eliminated. That is the major reason why we use inheritance. So here you don't have to rewrite the code, you just have to reuse the code. The concept of reusability comes with inheritance, where you're just reusing one function that is already written in operations class, which is inherited, let's say, for example, in circle class as well as square class. So in this case, circle is inheriting operations, square is also inheriting operations. Since one class is inherited by two different classes, we basically call it as hierarchical inheritance. Now, of course, your interview questions are not going to be as simple and easy as this. They're going to ask, if they're going to ask you types of inheritance, you'll explain that there are single, multi-level, multiple, hierarchical inheritance, and so on. So where do we use hierarchical inheritance in real life? If they ask you one question, let me know where we can use hierarchical inheritance. Let's say you're performing mathematical functions. In some mathematical functions, when you perform, let's say, differential calculus or anything like this, you need to perform so many steps. You need to write so many steps. So instead of writing so many steps in each class where you need to calculate them, you can just have them in a single class and inherit them in both the subclasses. Or one more example, we took the example of operations with a square. The same case can be taken when it comes to mathematical functions. Square is a simple function. We only have one line function here. There's not much about it. It's just a one line function. In this one line function, I don't want to rewrite it in its subclasses. We have two subclasses from operations. Let's assume again, as went earlier on, circle and square. Now both of them require square function. Both of them can directly inherit and reuse it. So such simple example can also be provided. There's no issue with it. Now, along with this, as always, since we have learned with bank account examples, you can take the same inheritance example, hierarchical inheritance, with a bank account example. There's a function called show balance. Showing the balance is same whether you use current account or savings account. So this bank account class can be inherited by two other classes called current account and savings account. Both of them need the same function to show the balance, but both of them need different functions to create an account and so on. So this is also one simple example that you can take up just to show how hierarchical inheritance works. Now, followed by hierarchical inheritance, the next thing is you have something called multi-level inheritance. Now, I hope everyone does understand that we are not going through code of these programs. We are not going through the coding part or in-depth of these programs, because our aim is to learn to answer in the face-to-face interviews as of now. So that is our major aim when it comes down to this. So let us go on and look at what exactly is multi-level inheritance. In multi-level inheritance, let's say you have a class A that is inherited by class B, that is then again inherited by class C. Now, I will be taking a couple of examples from here because there are a couple of very important things for us to understand, without which we will not be able to understand what is diamond problem, how do we solve it, and how to handle this. So to understand this, I will be taking one example when it comes down to multi-level inheritance. So to understand this in simple cases, let's say we have, again, as usual, bank account. Under bank account, we know we have two separate classes. Let's say there is savings account and current account. I'm taking the same example because we're sticking with the same real case examples most of the times. Now, you may know that there are different kinds of savings account. Now, when I say this, remember, all savings account will have same functionalities. All current accounts will have similar functionalities, but these two won't have similar functionalities together. Together, they'll have different functionalities. So when I have multiple types of savings account, let's say, for example, something like senior savings account, let's say junior savings account, or salaried savings account, or let's say we'll add one more thing like fixed deposit based savings account, and so on. Now, all of these are basically savings accounts. All of these interest or whatever it is, everything is calculated according to savings account. Only thing that may differ is percentage of interest, which is one variable. You can just create a variable called interest in each of these. But the function that is called to calculate interest is in savings account itself. So here, this, although it is a hybrid example in real case, you can also see multi-level inheritance here, where basic bank account has a subclass called savings account. In savings account, you have a subclass called seniors account. So senior account will access everything that is of savings account. Senior account will also be able to access everything of bank account. If you remember in our example, I'm just taking this, create account is only available as a function in bank account class. It's not available anywhere else. So since everything inherits bank account, the class bank account is inherited by everything, all of these classes, objects of all of these classes can have access to create account function, for example. Or instead of create account, you can also take example as show balance, because assuming create account may have different functionalities or different features, whether you want to show balance from savings accounts of senior, junior, salaried, FD, or current account, it's the same function. So it's accessed basically everywhere. So even a grandchild class can access the function of a grandparent class, not just parent class. I'm talking about a grandparent class. This is exactly the point why multi-level inheritance are required, because parent class will not have certain functions which grandparent class will have, and that functionality you need to implement in the grandchild class as well. So this is done by multi-level inheritance. So I'll just point it out. Single inheritance, as you know, one base class inherited by a single derived class. Multi-level inheritance, one base class inherited by a derived class. which in turn is inherited by another derived class. Again, when you talk about this in an interview, there's one thing that I'll state right away, because this is a face-to-face interview. I wanted to talk about most common questions and everything later on, but I'm just going to point this out right now, right away. Don't just stick to the definition. Anything that is asked, try to answer from a real world's perspective. Try to answer in a way that you know how it works, you know how it is implemented in real life. I'm just giving one example before going ahead so that everybody always remembers this. Take, for instance, machine learning. If definition of machine learning is asked, then I just state that machine learning is where one program learns from experience of previous examples to perform an action without human intervention. If I say this, it's the textbook definition physically as it is specified. But if I give an example rather, take an example, let's say a machine learning algorithm goes through 100 images of cats and dogs, and then you give one more images of cat or a dog, it will try to predict to the best of its knowledge, remembering all the features of previous 100 images, and guess or predict by a particular confidence level or guarantee level or accuracy that it either belongs to cat or a dog. So these are the kind of real case examples. When you provide, the interviewer will know that, hey, yes, this guy or this girl not only knows just the definition, but they also know how it works. They also know the logic. They also know the working. And that is what interviewers require. And that is what you should always remember. Please never stick with just the basic definition. I hope everybody will always remember this. Let's go on to the next part, that is hierarchical inheritance. When we talk about hierarchical inheritance, one base class is inherited by multiple derived classes. Now, before going ahead, I wanted to take this one example that I wanted to explain with one small example how multi-level inheritance works, and there's a reason why I'm doing that. So let us take one example. Let's say I'll take class derived 2. Let's call this as class derived 1. So if class derived 2 is inheriting derived 1, let's say this is the case, and just to ensure that everybody can see the whole program together, I'm just going to use the brackets in the same line. I hope that is all right with everyone. So here, let's take this for instance. Right, so we have a base class where we have a function, we have a derived class where we have a function, and we have another derived class where we have a same name function. Now, it's pretty clear when you create an object of derived 2, space, we'll call it as D2, and you call D2.fun, it's pretty clear that it only executes fun of derived 2. I can call this as infun1, infun2, let us call this as infun3. We know that it only executes infun3. There's no doubt about it. Let's just give it a try for our reference. So of course it says only infun3, but let me make one small change. Now, I hope everybody remembers what exactly a constructor is. A constructor is a function which has the same name as the class name, and it does not have a return type. So let us do the same for all the 3 classes. We have created constructors. I'll call this as in base. We'll call this as in derived 1, and we'll call this as in derived 2. This is what we have. Now, there's no other function. I'm not going to call any other function. All we are doing is just creating object of derived 2 class. We're just creating object of derived 2 class, nothing else. The moment you create an object of derived to class, since we are not calling any other function, it should only call the constructor, nothing else. Creating an object of derived to, it should call constructor of derived to. When you execute though, the output you get is different. It is in base, in derived 1, then in derived 2. Always remember, when you have multi-level inheritance, if derived 2 is deriving derived 1, it will internally create, in other words, think of it like this, it will internally create an object of derived 1 so that you can access all the functions of derived 1. See, you're inheriting a class called derived 1. How will you access functions of derived 1? When you have object of derived 1, that's the only way. Because if you remember back in our last session, we specified that whether it is private, protected, or public inheritance, private variables or private members and private functions of base class are inaccessible in derived class. So derived class cannot go inside a base class, but whatever is protected and whatever is public can be accessible in certain ways. So this happens because, in short, think of it like this: internally, derived 2 creates an object of derived 1. The moment an object of derived 1 is created, what happens? Its constructor will execute. But before executing its constructor, look at what derived 1 is doing. It is deriving base class. So it must create an object of base class as well. Before base class creates or object is created, before it starts its constructor, it sees if it's deriving anything else. No, since it's not deriving anything else, it will call its constructor, go back, give the object internally to derived 1. So derived 1 has an internal object which we have no control over, and derived 1 will give derived 2 an internal object which again we have no control over. Because this happens, because these two objects b1 and d1 are created, in base and in derived 1 are executed in order, after which in derived 2 is executed. This is a hugely important part that we need to know and understand before we learn what exactly is a diamond problem. So I hope this is clear to everyone. I hope it's clear. All right, now that it's clear, let's go ahead to the next part. Let's take a small program right now. Now that we understood how exactly this works, before going on to diamond problem, we still have one important thing, that is multiple inheritance. Remember, these are the two most important topics when it comes down to inheritance. So please make sure that you practice these topics really, really well. Let's look at what multiple inheritance is and what diamond inheritance is. Now, when we talk about multiple inheritance, multiple base classes are inherited by a single derived class. So multiple base classes are inherited by a single derived class. So let's see what sort of inheritance can this be used for, how it works, and so on. For that, let's just take one small example to begin with. We have taken these previous examples. Now, let's say, for instance, there is one account. I'm just giving one example. Let's say, for instance, there is one account which is a combination of multiple bank or multiple account combination. You have another something like joint account or something like that. Let's assume anything. You can join a savings account and current account. I'm just giving one example. This is not the real case. I'm just giving one example for us just to understand. So let's say we have something called savings account and current account, from which we are creating something like joint account, or Let's say, for example, you have all the features of a car, you have all the features of a truck. So you have many functions that a truck can do, many functions that a car can do, and you want to create one more class which can combine both of these. And functions can be performed even in this. Some functions which can only be performed in car, you can perform here. Some functions which can only be performed in truck also, you can perform here. So you can create something like a hybrid. Or one more example, just this is where you get into real case examples. Let's say, for example, you have a class which can perform calculations for a diesel or a vehicle which runs on either petroleum or petroleum. Let's call it as petrol vehicle. So there's a class called petrol vehicle which can perform all the functions based on petrol vehicle. It can calculate the mileage, it can calculate what is the price, based on the price, how much kilometers you're going, and all these sort of things. It can calculate when should be the next service, considering it's a petrol vehicle and everything. It can calculate all of these. Similarly, consider one more thing, that is diesel vehicle. So this also has its own set of features. It can calculate again how much kilometers will it run for per liter generally, or how much is the cost, and when should be the servicing happen often, where should it be taken, and so on. There may be different features, but a hybrid one will combine both. It will have functions of both the classes. So in this case, we are taking two base classes and inheriting it in a single derived class. So let us try this. Let us try to have at least two base classes, minimum two base classes. So let's call this as base 1 and base 2. So I'm just modifying the current program that is there. I'll just rename it as in base 1, in base 2. We'll just name it as base 1 and base 2. And let's say we have a derived class which will derive or inherit both base 1 and base 2. Now here's where one very important thing everybody needs to know and understand. When you're deriving two base classes, you can't derive them as public base 1 comma base 2. That is not possible. You have to derive them individually, separately. So you need to derive them as public base 1 and then public base 2. Both of them must be derived separately. So this is the important thing that we are supposed to know. So let's say we derive both of these and let's just create an object. No, there's no problem with this. It runs, there's no problem with this, because if you observe here, our derived class is inheriting base 1 first. Since it is deriving base 1 first, it's going to create an object of base 1 first. Then it is deriving base 2. So it will create an object of base 2 second. So the order in which constructors are written are in base 1, then in base 2, then the derived class constructor is called, which is in derived. So with this, if I change base 1 to base 2 and base 2 to base 1, will it print in base 1, in base 2, and in derived? Or will it do the opposite? Will it print first option, in base 1, then in base 2, then in derived? Or second option, in base 2 comes up first, then in base 1, and then in derived? Which one will it go for? Considering base 2 is inherited first and base 1 is inherited second. In this case, when you give it a try, of course, base 2 constructor is called first, as clear, because that's the first class you're inheriting. So its constructor is naturally called first. Now, there's one problem with multiple inheritance. There's a reason why Java does not allow multiple inheritance. There's a workaround for it, we'll see. But there's one little thing you need to know. Java doesn't allow multiple inheritance because it can cause an error called ambiguity. Ambiguity basically means confusion. So it can cause confusions is what it says. Now, if I have void fun here, a function, if I had void fun here as well, let's not create anything in our derived class. Let's leave it empty, nothing required in it. We create an object of derived class and we call d.fun. Now, if you observe here, there's a slight confusion here. We have a derived object d. We are calling function from the derived object. Will it call the function of base 1 or will it call function of base 2? Because you're inheriting base 2 as well and base 1 as well. You're inheriting both the classes. Since you're inheriting both the classes, you're unsure which one is to be taken up first or which one is to be called. So since this confusion exists, you will get an error saying request for member function, member of this class or this class function is ambiguous because it's confusing to the compiler. It says there are multiple candidates with the name function fun. There's one that belongs to base 1, there's another one that belongs to base 2. So it doesn't know which one to call. And this is where you get this particular error called ambiguity error. So this only happens when multiple base classes have same function name. All of them are inherited and you're calling it from derived class. So it doesn't know which one to call. If you had the same function in derived class also, then let's see what exactly happens. Let's say, for example, I don't call this function at all. If I don't call this function at all, then there's no error. The error only happens in runtime when the function is called. You can also try creating another function within derived class which prints in derived. If you compile it and run it, I think the program is not saved. Let's see. If you compile it and run it, we're not going to get anything. Yeah, because I've commented this. Let me uncomment it. If we compile and run it, now it says in derived, no problem. The reason there's no problem is because when you call function, it will call function here. It will never go to base class and it will never compare which function to call. It will only happen when you don't have a function here and it goes to the base classes to figure out which function to call. That is the problem that happens over here. Now, since we got to know what is the problem here in multiple inheritance, that is the reason why Java has removed it. Because in Java, why there is no multiple inheritance in Java? It's a pretty common question. A pretty common question when it comes down to interviews. You have multiple inheritance in C++. It's an important part of inheritance. Why is it not there in Java? See, think about this. Let's say we have two classes. Let's say we have two classes called circle and sphere. So to calculate surface area of or area of a circle or a radius of a circle, for example, you have the same function name, calculate radius of a circle given area. Here also, calculate radius of the sphere given area. Now, if you inherit both circle and sphere into one single class called, let's say, geometry, for example. So when I just call geometry, if I just create an object and if I call area or if I call radius by sending area, will it go to circle or will it go to sphere? We're not sure. That gets confusing. In real life, similarly, you will inherit a lot of classes. In one class and in another class, there are generally some functions called print. when you call print function, which class will it go for? If you have C1 and C2, both classes, where you have something called print function or plot function to draw a graph or something like that, and when both are used, when both are inherited in your program, which function will it go for? There's a slight confusion in it. So for this purpose, multiple inheritance is removed in Java. It is replaced by something else, which we will see ahead. But now, let us go on to the crux, let us go on to the major part of this. Let us go on to the important part here. That is diamond problem. Let us look at what this is, and I'll just state it right away. This is one of the most commonly asked interview question when it comes down to inheritance. Let's see what exactly it is. So as everybody know, diamond basically looks something like this. Not exactly like this, of course, something like this. So the same thing happens here as well. You have a base class which is inherited by two derived classes. Let's call it as derived 1 and derived 2. Now, these derived 1 and derived 2 classes are inherited by one more class called derived 3. This is a form of a diamond. So it's also called diamond inheritance. But there's some issues in it when it comes down to programming. Let's see what exactly it is. Let's try creating one very simple such code to understand what is the issue we get. So I'll call it as base derived 1 and derived 2. After derived 1 and derived 2, let's create one more called derived 3. Now, according to our diamond problem, the base class must be inherited by derived 1 and derived 2. And these two, derived 1 and 2, are supposed to be inherited by derived 3. So let's inherit base class within these two. So you have hierarchical inheritance here, and you have multiple inheritance here. It's a combination of both. So you can say even this is a hybrid. So let's just call void fun, and here I'll call it as in derived 1. Here we'll call it as just in base. Let me copy the same thing, paste it here and here. So this will say in derived 2, this will say in derived 3. So for our easier understanding, I'll just call it as D1, D2, D3, and in B. Sounds simple enough for us. Now, this is where the program starts to take shape. Now, when I have derived 3 object, let's say for example, derived 3 object, and I'm calling function fun, we know it calls in D3. There's no doubt about it. It's pretty clear. We also know if I remove this line, it's going to give us ambiguity because, sorry, yes, I have made one small mistake here. I've forgotten to inherit them. Derived 1 is inheriting base. Derived 2 should also be inheriting base, whereas derived 3 will inherit derived 1 and derived 2. Both classes must be inherited with separate access specifier. So let's try this now. Let's compile and run. It's pretty clear it prints in D3. It's simple. You're calling function from derived 3 object. It has a function called function that will execute. If you remove this line, however, derived 3 is inheriting derived 1 and 2. Derived 1 and 2 both have function. So we know what happens here. What happens? Think through. What happens here? Derived 3, object of derived 3 is calling a function called fun. This function called fun is available in derived 1 as well as derived 2. So it doesn't know which one to call. That's ambiguity, as we saw in the previous example. So it says, I don't know which one to call. So there's little confusion. But to make it clear, let's modify this slightly. I'm just going to call derived. I'm just going to create, let's say, constructors for now, and we'll only create object of derived 3. Now, here's the thing. Derived 3 is inheriting derived 1 as well as derived 2. Now, this is exactly what diamond problem is that I'll explain right away. So, derived 3 is inheriting derived 1 as well as derived 2. Let's go one step at a time. Derived 3 is inheriting derived 1. When you inherit derived 1, derived remembers, hey, I'm inheriting base class. So it implicitly creates an object of base class. Let's call that object of base class as B1. So for derived 1, you're creating an object of base class called B1. And after that, since you're deriving derived 1 here, again, I'll just point it out if it's confusing. Derived 3 is deriving derived 1. This derived 1 is deriving base class. Since it is deriving base class, it should have access to all functions of base class. How are functions of base class executed? Using an object. That is why object B1 is called here. So an object B1 is created for derived D1, and from derived D1, since it is being inherited in derived T3, an object D1 is, let's say, created here, so that derived 3 can access function of derived 1, and here derived 1 can access functions of base. I hope that's clear. Now let's go for the second part. Derived 2 is here. So since we are inheriting derived 2, we need an object of derived 2. Let's call it as D2. But if you want to create an object of derived 2 is also inheriting base. So derived 2 should also call its a base class and create an object. So derived 1 has called base class and created an object B1. Derived 2 will also call base class and create another object. Let's call it as B2. So now if you observe, there are 4 objects that are created. There are 2 base objects created, B1 and B2. So since there are 2 base objects created, the base class constructor is executed 2 times, because one object is for derived 1, another object is for derived 2. After this, you have derived 1 and derived 2 inherited, so even this should be executed. So we have created 2 separate objects of base class as B1 and B2. So that is why when you run this code, we don't have any function called fun. Let me modify this line by removing it. Now let us try running it. Let's compile it and run it. You get in base. If you observe, I'll just try explaining this quickly. So the moment you create an object of derived 3, there is this particular class. What's the first thing you're doing? Inheriting derived 1. If you're inheriting derived 1, you're going to go here. But to inherit derived 1, to create an object of derived 1, you need to create an object of base class, because that in turn is inheriting base. So this is inheriting base class. So first base class object is created, B1, for derived 1, and from derived 1, derived 3 object is created. So when we run this, first base class, then derived 1 class. So that is why you're getting in base and then in derived 1. After this, you have public derived 2. So it goes to derived 2, but derived 2 is again going to base. So since derived 2 requires base class object, and a new base class object B2 is created, then this derived 2 object can be created and given here, because derived 3 is inheriting it, called derived 2. So now when you see, it says in base and in derived 2 next to each other. This ends by after all this is done, then your derived3 object is created, which will print its constructor in D3. So there are two objects created of base class here, which is not necessarily important, but this is exactly what is called the diamond problem. The diamond problem occurs when two superclasses of a class, I'm just pointing this out. We have a class called derived3. Derived3 has two superclasses, derived2 and derived1. When derived2 and derived1 have one common base class called base, then in your case, base class functions will have two copies. They'll have two copies. When you have two copies, let's see what exactly happens when we have two copies. So here, to understand what happens when we have two copies, let's create void fun. Now that we understood how constructors work, let me just create void fun here in base class. And I'll just call derived3 d.fun. Just d.fun, that's it. I'll also comment everything else. So let me just take a screenshot of this to quickly explain this. Let's compile this first. The moment I compile this, it says request for member fun is ambiguous. Is it ambiguous? When is it ambiguous? It's ambiguous when you have multiple functions called fun. Do we have multiple functions called fun? Not at all. We have only a single function called fun. There's just one function whose name is fun throughout our program. Even though there's only one function with that name, we still get an error. The reason is this base class, as we stated earlier, this base class object is created separately for derived1 and separately for derived2 as well. Since it is created separately for derived1 as well as derived2, derived1 will have its own copy of this function. Derived2 will also have its own copy of this function, because both are going to base class through different object, let's say b1 and b2. So when you call derived3 dot function, it can go through derived2 also, it can go through derived1 also. It doesn't know which one to go through. Even though there's only one function, it doesn't know which superclass to go through to reach function. That is why you get ambiguous. It says there's only one candidate. There's not multiple candidate. If you observe, there's only one candidate. Even though there's only one candidate, you still get error. It won't call that function. This is called diamond problem. I hope this is clear. I hope this is easy for us to understand. I hope there's no confusions with this. This is called diamond problem. Let's now see how do we solve this. And again, the reason I'm taking a little more time towards diamond problem is that we have to know and understand that it is a very common question that is asked within interviews. Now, let us try if we can somehow solve this. To do this, I'm going to make this virtual. We know what virtual is. We have already learned it. So I'm just making virtual inheritance of base here. Let's see what happens. If I compile, there's no error. If I run, it runs only once. Now the reason here is constructor is called only once. When you make virtual, when you use a virtual keyword, we always need to know that there's only one object of base class that is created for derived1 as well as derived2. This is how we solve diamond inheritance problem in C++. Now, I'll just point this out. Solution to diamond problem is this. And this is hugely, hugely important. So please note this very, very well, because I'll just point it out. In a lot of interviews, you will often expect this particular question, stating that if you know how C++ works, if you know how object-oriented programming works, then explain how exactly diamond inheritance problem happens and how is it solved. So it's a very common question. Even if you guys do ask maybe your seniors, or do check through previous interviews by searching online or whatever it could be, you'll find that this has been asked a lot. So if it is still a bit new to you, I would request you to practice it, give it a try, take more examples, or go online, learn more about it if required. But ensure that you practice this a lot and go through this, because even if they ask you to explain this with a code, you should be easily able to. The main point. Now, let's go over to the next part. Now, going ahead from here, now we already got to know a lot of things about C++. We got to know every problem that, every question that can basically be asked when it comes down to inheritance, when it comes down to polymorphism as well. We got to know what is runtime, what is compile time polymorphism, which is also called method overloading. Runtime polymorphism is also called method overriding, and so on. So from here, now that we got to know all these basics, let's go through 2 or 3 final topics in C++ that are commonly asked. One is exception handling, other is STL. So these are a couple of important things that we all should know. What is exception handling and what is STL? To understand what is exception handling, we need to know the difference between compile time error and run time error. If I miss out a semicolon, the program won't even compile. It won't create an output file because there's something wrong in the program. So it can't execute. It knows it can't execute. So it won't even create an output file to execute. It won't even compile. That's your compile time error. It can be a syntax error or anything like this. Whereas runtime errors are things like, you may have a logical error. You're trying to create a program which calculates square, but instead of multiplying, you're using plus. That may not give you the right answer. For 2, it may give you the right answer. 2 plus 2 is 2 square itself. But for every other number, it's going to give you a wrong answer. That's a logical error, also runtime. But another runtime error is particular exceptions that your program may face. Exceptional cases. That's how the word came up. So exception, for instance, let's say you're creating a program to divide 2 numbers. User enters 2 numbers like 5 and 2. 5 divided by 2 gives you 2.5 and so on. But what if user gives a number, first number as 5 and second number as 0? What happens in that case? Division by 0 is not possible. It's impossible. It's basically not feasible in case at all. So it just crashes the program, sending a message saying this is not possible. So when such exceptions happen, your program just crashes out. It doesn't execute the next statements whatsoever. It directly exits out. To solve this, we need to handle this exceptional cases. That is exactly what is called exception handling. So let's look at what it is and what sort of interview questions you can expect out of this. Now, just to remember, exception handling is not there in C. It is only there in C++, Java, and Python. It's available in all these 3 languages, but not in C. And features in each language differ. In C++, you only have 3 keywords for exception handling. In Java, you have 5 keywords for exception handling. So there are a few differences, but the 3 keywords which are there are common for both. So exception handling handles certain runtime errors. They are also called unchecked errors. So I'm just stating these points because these are important for us to know. They're also called unchecked errors. So what is errors that are checked that compiler can check? Like semicolon is missing, or instead of cout, you type COT, which is gonna give you an error, and so on. Unchecked errors is the ones that it doesn't check, like divide by zero. It can't understand this until you give an input, that is during runtime. So those exceptions go unchecked. So that is basically what is called as unchecked errors or certain runtime errors. You can handle these exceptional cases. So to do this, there are three particular keywords in C++ that we need to know. So why do we need exception handling? What is the use of it? One common question. What is the use of exception handling? Why do we need it? So the best example I'm going to give you guys is, you can question the interviewer back in this case to let them know that you know this well as well. Think about this. It's in C++, it's in Java, it's in Python, and we know Android is built on top of Java. So Android programming is built on top of Java as well. So in Java, if you have any error, like you are unable to access a file, you are unable to access internet, you are unable to access Bluetooth, anything in your Android phone, since you're unable to access it, for example, you're supposed to access a website and log in. Now, when you try to log in, if there's no internet, it's not going to give you the response from the website. If there's no response, it may give you some exception and crash the program. Instead of crashing the program, you can create exception handling, particularly to check if there is internet or not. Similarly, when two numbers are divided, even in calculator, when you use calculator in your Android phone, when two numbers are divided and the second number is 0, it should just give out a message that it can't divide by 0, or it shouldn't do anything instead of crashing out. To avoid crashing out, we know that the exception we are trying to handle is an arithmetic exception. So we can solve, or we can identify this arithmetic exception and solve it by particularly looking for and searching for arithmetic exception here. So this ensures that programs doesn't crash and it continues execution by giving the user a warning message. Like if internet is not found, it can give the user a warning message saying internet not found, or GPS not found, or location is not switched on, or division by 0 not available. Otherwise, it would just crash the program. That is the basic reason why exception handling is utilized. I'll just point this out. Utilized to maintain, or utilized to continue execution of the program even when a situation, even when an exceptional situation arises where the program may crash otherwise. That is the basic idea. Now, I'm not going to take a long time within this. Let me just take a small example to quickly go through this, because I want to explain the three keywords that are there for exception handling. When they ask you what is exception handling, how does it work, you can also add to this. See, the more you know, the more you add, the better it is. That doesn't mean you should just speak about everything. The moment they ask about exception handling, you shouldn't just say like exception handling belongs to C++ and you start explaining everything about C++. No point in that. If they ask about exception handling, you can say exception handling is implemented in these programming languages and it's implemented a little differently in C++ and Java. In C++, these are the keywords that are there. In Java, these are the additional keywords that are there, and this is what they mean. You can explain that. And this is why they're used. You can explain that. And that adds more credibility that, hey, this guy or this girl knows how these work. So I'm just going to take very quickly a couple of examples just to go through them. So take this for instance. I'm just going to take Very quickly, I won't even take input read from the user. I'll just take this something like int a equals 10 and int b equals 0. And all I'm performing is int c equals a by b. We know this is not possible. This is supposed to give us an error. So when I print c and go to next line and I print something like end of program, thank you, for example, here this particular line is not going to execute because there's an error here. When this exceptional case happens here, the program crashes immediately. It doesn't go to any line ahead. It'll crash right there. So that is exactly what happens here. It says something like floating point exception, code dumped. It exits right there. It's not even going to go ahead. So here it is called floating point exception. Let's just remember that name, not to worry about it too much. Now, to solve this, all I need to do is, I know error comes in this line. So what I'm going to do here is just put it in a block called try. Try is a block. Block is within a couple of brackets. So in this block, you will write all the statements which can give you errors. So I'll just declare int c separately here so that we can access it, so that it's not limited only to these brackets. So if there is an exception found, if there is any error, then we're going to use another block called catch, and catch should always be immediately after try. Let's just catch the exception here and let's just print it as do not divide by 0. And let's end this. So if there is an error, it will go to catch, it will print do not divide by 0 and continue. If, on the other hand, there's no error here, there's no exception here, it will continue to the next line. So the next line, we're going to print that value. So let's keep it local itself, not to worry. So all that we are doing here is, if this gives an error, it doesn't go to the next line. If it gives an error, it directly switches over to catch, executes whatever is in catch, and goes to next statement and continues the execution of program normally as expected. If it doesn't give an error, it will go to the next line. Since there's no error, there's no exception to catch here. Since there's no exception, it directly goes to the next line after catch. That's the basic idea. So here, when you observe this, you get one little error where it says it doesn't know what exception E means. That's because exception E is a particular thing we have in Java. In C++, to catch an exception, we need to use a constant character pointer, E. That's the difference. Again, we don't need to know too much about it. But for now, let's just remember this. So let's compile and run it. It says floating point exception. It says floating point exception. Is it going to the catch part? Let's look at this. Is it? It's not. Even though, just to point this out, even though we are dividing by 0, it's not going to the catch part. Instead, it is directly going ahead and stating that there's this particular error and exiting. Now, observe, I'll just point this out. There are a couple of simple things that we should know from basics. I'll just point it out. There's a couple of things that we should know from basics. That is, whenever you divide two variables, the result should always be stored in float, unless you implicitly convert it to int here. So I'm going to store this in float. That is why we had floating point exception. Let's try compiling this and see what happens now. Even now, we get the exact same thing, that is floating point exception itself. Now, here's the basic idea. There are multiple ways we can solve this. I'm just going to state this in short, how we can particularly solve this. There are multiple ways we can solve this. Now, one way for me to explain this in short, in the easiest way, is to add one more keyword to explain how exactly this works. I'm just going to add one more keyword so you guys can get to know how this works. Because remember, as I stated, exception handling in C++ has three keywords, that is try, catch, and throw. Always remember, try must be immediately followed by catch. And throw is when you want to send an exception from one function to another function. So let's try how exactly this works in short. That is, with our case, again, I'll repeat, with two cases. One, with our case of throw, and second, without our case of throw. Now, let's take this. You can also try making this double and so on. You can try to change this to anything that you want. That's completely up to you. That's totally your choice. So here, whether it is divide by zero or whether it is any other standard exception, like something is null, you're unable to access internet or whatever it could be, we basically solve them with just your try catch block. If you really need to involve one more function and send the error message back to main, in only those cases, I'll repeat, in only those cases, we use this basic concept called throw. Now, to understand this, I'm just going to take one simple function. Let's call it as double division of int x comma int y, where we're going to divide x and y in this function and try to get the result. Now, in this case, can I divide them when y value is 0? If y is equal to 0, can I divide them? I can't. Basically, we know that. So if y is 0, what we will do is create our own exception and throw it, because we are seeing it's not working. This is not working. It's just saying floating point exception and it's exiting no matter what we try. So what we're going to do here is, if the second value is 0, we're going to try throwing our own exception first. So let's throw our own exception here called division by 0 is not allowed. Let's just show this particular message. Since it's an error message, caution, let's just add a couple of exclamation marks just to show the seriousness of this message. So from here, let's go ahead. Otherwise, if this is the case, then you throw this, else you can return a by b. That's it. So a by b, let's keep it as it is. So this is the basic idea. Now you don't even need else here, just to point out, because if this condition is true, you throw. If this condition is false, it directly comes here and returns. So both of these statements are exiting the function. So there's no need of else, but let us keep it. Now here, all that we are doing in our cases, we are just trying to calculate C equals division of a comma b. So we have our division function, which takes two variables. Those two variables are a and b. We are sending these variables to division function as x and y, and we're checking if the second value is 0. If it is, we're sending this. If not, we're sending the number. Now, since we are throwing an exception here, we need to catch it here. And catch, if we do, we need to catch it in the catch block immediately after try. So that is what we are doing here. Instead of E, you can write it as anything. Whatever exception you're throwing here, that will be caught here within this name. It is user defined, so you can give any name you like. So let's just receive it and try printing it. Let's try this out. Let's compile it. Now I can see one small error stating that A was not declared in the scope. All right, there's one mistake. This is X and Y is what I've used. I'm supposed to keep this as X and Y. And also there's a C, variable C. So let's just declare that as well. You can just put something like double C. That's enough. So it was supposed to be x comma y, but since we had a and b over here, I've just typed a and b here. So now that it's solved, let's try compiling this now. When I compile that, there's no error. When I run this, it says division by 0 is not allowed. That is, whatever we have thrown from here, it is caught here. It is caught here and we're able to print here. After this exception is caught, it then continues the normal execution of your program. That is exactly what is happening here. So in short, just remember this. Try is a block in C++. Try is a block where you can write a set of code, and whatever code you're writing here, let's say it's in a function, you can throw an exception from there. You can create your own exceptional cases. If a file is not found, throw an exception. If you are unable to access internet, throw an exception. If you receive 0 as a value, you can throw an exception. If you receive null as a value, you can throw exception. Any of these you guys can do. And then that exception, you just have to print and then continue ahead with the program. If after printing it, if you need to do some other step, you can do those steps here if you want to do some other steps. If not, go ahead with the program as expected. So this is how try, catch, and throw works in C++. So just pointing out, there are a few standard exceptions in C++. I'm just pointing this out. What is the difference between exception handling in C++ and Java? Because we need to know that there are a lot of differences between C++ and Java. So one of the major differences also comes up in exception handling. In exception handling, Java has a lot more exceptions that it can handle. It is built better. In C++, you don't have so much exception. You have something like length error, you have something like out of range, you have a few, but in C++, most of the times you need to throw your own exception. Like we tried earlier, did it work? No, we had to do our own function and throw our own exceptions. But in Java, you have a lot of inbuilt exceptions and two more keywords as well that are throws and finally. We'll look at those ahead as well. But before going over to those, let's go ahead to the next part, that is STL. And this, again, I'll point this out. This is also hugely, hugely important. There are a couple of things. STL, namespace, templates, these definitions of these, what do they do in short, are hugely, hugely important. So I'll just point this out. STL is having a lot of inbuilt functionality for you. It's basically what we call it a standard library. This standard library consists of many data structures that you can directly implement. So STL consists of data structure code that can be directly implemented. See, in Java, you have, again, I'll keep on giving you guys the differences between C++ and Java, because when it's oops, it's something hugely important. In Java, you have collections which have inbuilt data structure functions which you can directly implement. In STL also, you have inbuilt data structure functions that you can directly implement. You have everything including heap, binary search, sorting, all of these things are available in STL. So basically, I'm not going to go into STL in depth, but I'm just pointing out STL is standard library that you have, which standard template library, not just standard library, I'll just state it. It's standard template library, which has multiple data structures that you can implement within them. And these are a lot of things. Like they're generally divided into something called algorithms, containers, and everything, but you don't need to worry about that. I'm just going to give you one example, whether it is a list or whether it is arrays, whether it is queues, whatever you have, all are available here, even including map, set, everything are available here, which you can directly implement. So you don't have to worry about implementing the code to create these data structures. You can directly run, you can directly call using this. So you have to use certain header files to perform this. So I'm not going to explain those as of now, but just remember that these can be used in this particular way for now. Now going ahead, there are a couple of other things that we need to know. Basic things. There's something called namespace and there's something called template. Now namespace we see here in pretty much every program. There's something called using namespace standard. What is this namespace? Similarly, in the name STL, you can also see that there's something called standard template library. What is a template? Let's just try observing what they are. So here's the basic thing. Namespace helps to, again, these basic things are what are generally asked. So it's something we should always know. So that's why I'm pointing to these out as quickly as possible. So namespaces help connect or organize many classes so that you can use the functions to use, their functions. So many things are based on classes and objects over here. So when you use namespace standard, there's a lot of things that are stored within standard, whether it is something like cout, cin, endl. All of these are basically within the namespace standard. They are organized. All of these functions and everything are organized within this namespace. So once you use namespace and you use this function, it will remember, hey, this is what console output is within standard, and your program will get to understand what to do with this. And all of this is built in within C++ called a global standard framework, or also called as global standard namespace. So this global standard namespace will directly use cout, endl, and everything. Why do we need namespace? So that we don't specify where does cout, endl, and everything belong to. If you are using a separate function of your own, where you have a function called cout, then you shouldn't use it like this. Instead, you should use standard scope resolution operator everywhere. But for now, the major point here is that we should know, as of now, is that using namespace, it stores everything together, and we don't have to use complete name later on because it automatically remembers it by the namespace. So this is often used in XML, HTML also, if you guys observe. So whenever this is asked for, you can always compare with XML and HTML. Also, as stated, yes, it also avoids naming conflicts, because in case you have a function called cout, which belongs to namespace standard, and you create one more function called cout by yourself. When it is called, you don't know which one should be called. It gets confused. Your compiler gets confused. So your own function can be called by just using cout, and the namespace standard function can be called using standard namespace cout. You can create your own namespaces and so on. I will not be going in depth within this. I just want to point out to what they are so that you can answer them when they're asked in interviews. And finally, one of the final topics in C++ that you need to know is something called templates. So templates are used to create generic classes and generic functions. Now, what is this generic class and generic functions? Generic classes and generic functions help create generic programming. Now comes even more confusion. I said templates Then I went to generic classes functions. Then I went to generic programming. This is now it's getting a little more confusing. Let's try to remove the confusion and try to understand what this exactly is. See, the basic idea is templates. As you know, Microsoft Word, you have a template for doing something. PowerPoint, you may have a template to create your presentations and so on. Same way, you can create certain templates for functions and classes. Templates for functions and classes can be created. Using these templates, you can create your own versions of functions and classes. Any template you basically create are generic templates. There is generic functions and generic classes. Now these can be used for you to create your own modified objects or modified values later on. To understand this better, I'm going to take a very, very small example, not a big example at all. I'll just take int main. Let's just return a value. So let's say, for example, we want to create a template to a template class. Let's say we create a template class which is going to add two numbers. That's what we are doing. A template class to add two numbers. So I'm just going to create a template. This template is not of a function, of a class. Since it's of a class, I'll just call class temp, or just t in short also can be taken up. Now the performance, the thing we need to do is add two things, and these two things must belong to this class t. So I'm just going to take them as references: t ampersand n1 and t ampersand n2. Now we know why we use ampersand, because they are reference variables. I think I missed out. All right, perfect. So here, let me just take t ampersand n1 and t ampersand n2. Now, let's just say we need to add the result. Since we need to add the result, we need to create again a variable of this type itself, a variable of this class type. Now, we are not specifying any data type. We are not specifying any data type by ourselves. Everywhere we are using just t. That is why it is called generic. It can be used for any data type. That is the point. If I call from float, it's going to use float. If I call from int, it's going to use int. That is the main intention. We are creating a generic class which can be used for any data type. Say, for example, a generic class can be created using templates which can perform addition of any data types. I hope this, in short, explains how this works. So I can't store something like int result equals n1 plus n2. It has to be t result equals n1 plus n2. That's it. And whatever that is, we are returning it back to the user to print or see whatever it is. So let's take two examples. Int a equals 5, b equals 10. And let's also take float a equals 5.5, b equals 4.5. Now, when I print add of a comma b, it's going to perform that addition with integers. The same thing when I use add of. So I can't use a and b again. So let's use c and d, because you can't have multiple variables with the same name in the same scope. Let's use c and d and use end l. Now, the first line is supposed to print an integer result. Second line is supposed to print a floating point result, because we are sending two floating point variables. They are received as two floating point variables. The result is also floating point only, the same t. So let's see whether it works. So let's try compiling this. We have one small error here. Let's see what exactly is the error. It says C++ forbids declaration of add with no type. Yeah, see, it's one small mistake that I've done. This add function is supposed to return something. This generic function called add, we are returning something, right? And that result is of what type? It's of type t. Now I'll just point this out without taking too much time. We're receiving n1 and n2 of type t. whatever this type t is the same type that we are sending here. If we are sending integer, it's going to receive as integer. And we are creating one more variable where we are adding them and storing the result. So whatever type it is, it's going to add and store the result in same type. After that, if you're returning the value, returning a response, you should return that data type as well. That is what we have forgotten to add here. Basically, I have forgotten to add here. Let's add the return type as t as well. Now let us see if it works. Let's compile, let's run. You get 15 and 10. It's basically adding both values. So 5.5 plus 4.5 is basically 10. It's not taking 5.5 and 4.5 as integers and adding only 5 and 4. So if I take 4.3, for example, just to check, if I take 4.3, for example, it gives 9.8 and 15. So for the first one, it is integer. For the second one, it is float. So these are templates, and they are used to create generic classes and generic functions. Generic classes and generic functions do not have certain data types. They take whatever data type it is there, perform some action, and return the value. These are generic, and you can change the data type and values however you want when you call them. And this is used in creating generic programming where you can send any data type. Basically, that is exactly what is called templates. So these are just placeholder names. So I'll just point this out. This T that you have, it's just a placeholder name. This placeholder name will be replaced by the data type when you're supposed to execute. Say, for example, in real case, in real life, you want to implement. Again, everything we're going through real world examples. In real life, you want to implement sorting. But you want to implement sorting of integers as well and float values as well. So if you want to sort integers, you need to create a separate function. If you want to perform sorting of floating values, you again need to create a separate function. Instead of creating separate functions, instead of creating separate functions for each type, each data type, use generic programming. And how will you use generic programming? By creating generic classes and generic functions. How will you create generic classes and generic functions? By using templates. That is the basic point of templates. So these are the major and most important concepts that you need to know when it comes down to object-oriented programming within C++. So with this done, now we can go ahead to the next important part, that is Java. So when we start working with Java, again, first thing is Java is again built on top of C++. It's a big extension of C++. That we basically know. It's a huge extension of C++, and it has a lot of features removed from C and C++. There's a lot of features that are not there. There's so many things that come up in Java, and this is where you can expect a lot of questions, because over the last two sessions also I've stated the same, and I'll state the same again. They hire most of the times developers, full stack developers, who should know Java. So if you have specified that you know Java, you're supposed to know certain things which are most commonly asked. In the next session, we're going to go through what is commonly asked in Java, and once it is done, we'll directly go on to data structures and algorithms and look at all the programs that are supposed to be asked over there. So before going ahead, I would also suggest that as some of you have asked, tell some programs which we have to learn before interview so that we can learn apart from these sessions. Yes, programs, when we talk about it, the first thing I would always say is sorting algorithms. What are the different sorting algorithms? How are they different? How is merge sort different from heap sort? How is bubble sort different from insertion sort? How is selection sort different from merge sort? Which is the better one? Which is the worst one? Why is quick sort called quick sort? How does it work? These are some things that we need to know when it comes down to programs, when it comes down to algorithmic programs. And followed by this, there are a lot of algorithms that we have to, I'll repeat this, we have to learn, like what is greedy algorithm, what is dynamic programming, how it works, what are the different kind of graph algorithms that we have, and so on. Some basic stuff, not entirely in detail, but at least enough so that you can answer with confidence that yes, I know something about it. That is important. And it's also important for us to know a lot about data structures, like how linked list works, double linked list works, graphs work, and all. So these are something that are hugely important as well. It's not a straight up competitive coding exam where you're only asked programming. You're asked logical questions on programming languages rather. So if you want to learn programs, I would suggest you to go through more on data structures and algorithms. So I hope today's session has been useful and helpful to all of you. We'll catch up in the next session. Till then, keep studying, keep working on, and we'll catch up. Thank you. Yeah, I'll be sharing the link as well for the session for your reference. Right. Thanks a lot for the nice feedback as always. Very glad to hear that. So I've shared the link as well for today's session. Please do go through it, and we'll catch up in the next session. Have a good time, guys. You guys can just open the link once. That will open up in a browser, which you can access later on.